The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon and welcome to the Aculon series webinar regarding our NanoProof series PCB waterproof protection technology. Thank you for joining us this afternoon. My name is Edward Hughes. I'm the CEO of Aculon and we are the producers of the NanoProof series. I'm joined here today with Mario Gattuso, who's our Senior Business Development Manager in charge of our electronics business. This afternoon, over the next 30 to 40 minutes, we're going to give you an overview of Aculon, talk a bit about the NanoProof series and the technology, talk about some of the application methods, give you a comparison with some competitive alternatives such as PARYLENE and conformal coatings, and then go into some case studies for the use of this product. And finally, we're going to finish with a question and answer session. This presentation will be available for downloading after the session. We will send to each of the registrants a link on this. The session is being recorded, so you can also have a link to that and share that with your colleagues. If you have any questions, please input them into the question box as you go along, and then we'll try and tackle as many of those as we can at the end of the session. Aculon is a leading provider of surface modification technologies. We like to think of ourselves as surface solution experts in that we develop and produce treatments and technologies to modify a broad variety of surfaces, including metals, glass, and polymers. Our treatments are hydrophobic, super hydrophobic, oleophobic, hydrophilic, adhesion promoting treatments, and they're all very thin and easy to apply. They need minimal capital equipment, and so we, as a business, we try to focus on things that are solution-based and could be sprayed or dipped or wiped on and don't require a vacuum chamber or any expensive capital equipment. We have three business units: the electronics one, which we're going to talk about, one of the product ranges here today, an oil and gas business, and a specialty business. Our business is to produce chemistry and to sell chemistry to help our customers modify surfaces to enhance the performance of their products. We're based here in San Diego. This is where we do our development, research, and application engineering. We ship globally and we manufacture in various locations in the United States. We have a worldwide distribution network. In Europe, we're partnered with a company called Caplink, provides logistics and sales and representation. In Asia, we have a number of distributors providing to each of those key markets for electronics. Here in the US, we'll supply and ship from Aculon in San Diego. Our NanoProof series is designed to provide a range of products that will protect printed circuit boards from humidity all the way to through full water immersion. We launched this product range in the middle of last year, and we were very pleased earlier this year to receive the 2016 New Product Introduction Award from Circuits Assembly. Many of you will know why you need waterproofing on your devices. In real life, obviously, consumers and operators actually, will come into contact with water and will damage their devices, whether it's outdoors for electronics where it could be impacted by rain or irrigation or humidity, or whether it's the consumer splashing water on it or even potentially dropping it in a pool. These devices can have water damage, causing the device to fail and to short. As we think about water damage, we've tried to encourage all our customers as we start a project with them to think about what level of water protection is necessary. And so we tend to use the IPX scale, and the IPX scale from 0 to 8 provides varying degrees of protection, with 0 having no protection through to all the way something being submersed in water for long periods of time. And we think it's important up front to try to understand what level of protection you want, because that's going to determine both the treatment that we would recommend as well as the complexity with which it's likely to be achieved. So we'll use this when we work with customers and saying, often customers say, I want to have my device waterproofed. And we'll say, well, from what level of waterproofing do you need? And this provides a good scale from which to do that. So we can then, as I say, recommend which treatments are appropriate. We've also looked at, through experience and through discussions with customers, what would make sense as a recommended IPX level for some of the common devices. When someone says I want waterproofing, that means varying things to us. So we've taken some devices where it could be hearing aids, where you're looking for protection against spraying water, or whether you could be looking at computers or automotive electronics or Bluetooth headsets. You could be looking for protection against splashing water. And then in a number of outdoor environments where you could be needing to protect against potentially irrigation systems, heavy rain, being hit with a hose, etc. And you've got outdoor lighting, junction boxes, any outdoor electronics such as doorbells, etc. And then you have mobile device manufacturers that are often looking for between level 6 and level 7 protection here for a cell phone. So as we start conversation with customers, we always ask them, what are you looking for, and so we can get a bit more specific around what kind of criteria is success. And it's also important to understand that, because as you get higher in the IPX levels, the degree of complexity goes up. So we like to kind of use an analogy. It's like mountain climbing. If you're climbing low hills or medium hills, you can probably do that fairly easily with not a great deal of training or specialized equipment. But when you start to climb Mount Everest, then you need training, specialized equipment, and a team to do that, and it's going to take you longer to prepare to do that than it does if you're taking climbing a small hill. So the complexity goes up as the level goes up, and so that's something to bear in mind, obviously, as some of you are thinking about potentially waterproofing either existing devices or for new models coming up. Obviously, the greater the waterproof protection you need, then the greater the complexity is likely to be, and that impacts this time as well. So with that, let me turn over to my colleague Mario Gattuso to talk a bit about the NanoProof series of products. Take it away, Mario.
Okay, so we have identified a range of products that offer a range of protection levels that meet a range of budgets. All of these treatments utilize proprietary technology. All of these technologies are manufactured right here at Aculon, and they surpass many of the competitive coatings in performance and ease of use, and there's several areas where there's some distinct benefits that we'll get into. As these are liquid coatings, the application equipment is affordable and readily available and offers a wide range of flexibility in determining the procedure for treating your parts. Some of the key benefits to NanoProof are reducing product returns due to water damage, so you can prevent failures in the field that are isolated and don't necessarily kick off any water indication sensors that would result in a warranty claim. They improve your production yields, as rework is possible after coating. So if you find that there's a part requiring rework but it's already been coated, the NanoProof coating, none of them will prevent you from doing rework. In some cases, you can do rework without even removing the coating first. Another key process benefit is that minimal masking is required for the treatment of parts. In some cases, you can even get away with no masking whatsoever, as you can make electrical connections right through the coating. Another key factor that, of course, is in the back of everyone's mind, is there's no toxicity or health issues associated with these treatments. They can be easily implemented in a factory environment and used by skilled and unskilled workers alike. And then the other key benefit is it is affordable. It is reasonably priced so that it can be easily implemented across numerous types of applications without causing a budgetary issue. So here we have a comparison of the 4 main NanoProof products. I'm not going to go over every single detail here. It will be available in the copy that we emailed to you after the presentation so you can review the notes here. We start at NanoProof 1.0, which is our entry-level good enough treatment. Oftentimes for just a minimal exposure conditions, it's good enough to get you to IPX2, 3, even 4. Very reasonably priced, a very thin coating, so masking is almost never required with this product. Very easy to process. For our mid-level coatings, we have 3.5 and 4.0. They're a similar family of chemistries. They're also hydrophobic, but they're not oleophobic, so they don't repel oils. These are siloxane-based treatments. Key benefits to these treatments are that they are thicker and offer more protection than the 1.0, getting you into the range of IPX3, 4, 5, even 6, without needing to, and also not needing to mask. So they offer what we call push-through connectivity, where you can actually make electrical connections through the coating, so no masking needs to be done. And then our most robust line, NanoProof 5.1, is a fluorinated base treatment, and it offers repellency to water, repellency to oil, so it's extremely robust. It's going to repel oil, solvents, gas. It's very robust. Not much is going to damage it on a board, so it's for aggressive environments, and it is the best barrier that we offer. It's helping to achieve, in some cases, up to IPX7 if a proper procedure is identified. And in many cases, it's used in conjunction with 3.5 or 4.0 to add additional protection to high voltage components. Because of the extra robustness, it does not allow for the push-through connectivity of the other materials after it's allowed to dry. But the one nice option is you can add a little bit of solvent to a connector, which will soften the treatment and allow you to make a connection while still protecting it long term. Here you can see in the middle and on the left 2 boards that have been coated, and you can see that they're glowing under a UV light. That's because every NanoProof product that we sell contains a UV tracer standard. Most of the equipment that applies these materials comes along with UV inspection equipment or lights, so that you can easily qualitatively confirm you've applied the treatment in the right areas on the board. On the right, you can see that the backside of the board has not been treated and it's not glowing. This just shows an example of how we measure the repellent nature of the coatings. So this is what we use is a goniometer. It measures the water contact angles on the board. And so you can see here NanoProof 5.1 is highly repellent to water and oil in the range of 120 to 125 degree water contact angles and 80 to 90 degree oil contact angles. We got into one of the key benefits of NanoProof is that it does not impact key components, so it minimalizes the amount of masking and keep out areas. In many cases you can treat the antenna, headphones, microphones, buttons, in some cases even speakers and sealed LCD displays. This is all on a application by application and material basis, but there's a significant amount of masking and process complication that is avoided by using the NanoProof material. So I'm sure you're wondering, how do we qualify the performance of each of these materials? And so we've done extensive testing with the IP test boards, which essentially have electronic combs that you can run current through, and they can be exposed directly to water or different solutions. So what we do is, utilizing the D pattern, we isolate that D pattern and we coat our materials onto the D pattern, and we run it at several different voltages. The testing here is done at 3 volts, 6 volts, and 12 volts. by inserting the treated board into water and salt water, putting a voltage across it and measuring the current leakage, and then observing the impact on the board. And so what you can see here is the impact that the water has on the board at various voltages. On the left side, these are all measurements on an untreated board put into water. And so you can see that at 3 volts, 6 volts, and 12 volts, at different rates, of course, there is significant current leakage and board failure almost immediately. Whereas coated with NanoProof 4.0, what you can see on the right is a green line going across the baseline, which is indicating 0 milliamps. So there is 0 current leakage. And that green line is also covering the 3 volt and 6 volt testing, which are also 0 milliamps underneath it. So at 3 volts, 6 volts, and 12 volts for 60 minutes in water, the 4.0 coated board has 0 current leakage, and then on review of the boards, you can see visually that there is almost no oxidation or breakdown versus the coated, uncoated boards, which are nearly destroyed. This technical paper is available for download on our website, so the link to this technical paper will be sent out along with the video and PDF of this recording after the webinar is done, so you will have easy access to that. It's also available on our website if you want to take the time to look for it sooner. So we'll get into some of the application options now. And as you know, it's a liquid treatment, so there's 3 key areas that can be utilized to apply the material: spray application, dispense application, and using a dipping process. Spray is always preferred. It is a extremely reliable and repeatable process for a high production environment, and it's an extremely efficient use of the material. Dispensing is also good typically for spot treatment of sensitive areas. So what we'll often do is spray an entire board, and for a high voltage or particularly sensitive component, we will spot dispense extra material, or sometimes even a different, more robust material on that sensitive component to get that added protection. The other option is dipping, which will do the job, but it's a bit more difficult to control just because of all the different parameters that go into maintaining a dip bath, the concentration of the solution, and making sure that contaminants have not fouled the solution. So it is typically not recommended for high volume production due to those complexities, but it can be utilized for small volume, or if it is required for your process, we can assist with implementing that. So here, more information that Aculon, we will work with you to determine the best application process. There are some details here on some general recommended processes for spraying, dispensing, and dipping. The key thing to note is that these are general recommendations, and that every board, every application and product is unique, and direct collaboration and iteration is always recommended. We often find that after an initial trial, there will be some failures, and then by identifying where the failures are, they can be worked out by modifying the process to best fit the challenges of your board. So it's not necessarily a material failure, it's a process issue, and those process issues can always be worked out. So through a few iterations, whether it's a spray, dispense, or dip process, we can usually achieve success and get to the IPX levels that you're looking for. And so now we're going to show an example of the automated spray systems that are utilized for spraying NanoProof. And so this is a automated system called the Delta 6 from PVA. And as you can see, it's just a spray head that's mounted on a robot, and it can be used in any pattern that is appropriate for the board. What you can't see here is that these offer racking systems for multiple nozzles, multiple spray heads, spray and dispense heads. So you can customize it so that if multiple applications or products are needed, they can be done on one board in one quick process. And then here you can see you do not necessarily need to use an automated piece of equipment. There's manual dispensing equipment, and so that can be utilized for small volumes, for R&D work. So a bunch of programming isn't required as you work on a new project. And then the sky's really the limit as far as process options for high throughput scenarios, high volumes. You can get these pieces of equipment inline so that they're pretty much hands-off. So now we'll get into comparisons with some of the key competitors, or traditional conformal coatings and PARYLENE. So NanoProof advantages over conformal coatings. NanoProof provides effective water protection up to full submersion, where many of the traditional conformal coatings fail and just do not meet those requirements, and that's going to lead to reduced return rates. Our application process is extremely flexible. As mentioned before, you can spray, dip, and dispense, and no cure is required. So there's no oven cure, there's no UV cure, there's no batch processing. This can all be in line and very quick. Minimal capital equipment is needed. Obviously there's the automated equipment you saw before, but it is quite simple, and relatively speaking to the cost of the equipment for other processes, vacuum deposition, cure ovens, UV cure systems, it's very, very affordable and reasonably priced. Another benefit is that the production process is continuous. There's no batch processing, there's no multiple hours of parts sitting in an oven or in a vacuum chamber. Then the other key area that is unique to the NanoProof line is the ability for push-through connectivity, the ability to coat an entire board and then go back several hours later as you build your product and have to connect several boards. You can still make those connections with your push pins or flex connectors, or however you're electrically connecting your components. Other key area that is very significant is the ability to rework. So this is going to save you significant amounts of scrap boards or wasted time trying to physically remove a difficult conformal coating. It's going to have significant impacts on your reject rate of parts. Going along with the push-through connectivity, big benefit is no masking is needed with the push-through connectivity, and saves significant time on masking and demasking. It really simplifies your process. Due to the continuous process, you're looking at less than a minute for treating a part versus several hours in a chamber. And then of course the material is non-toxic and very safe to use. Then we will get into some of the advantages of our PARYLENE coatings. Biggest advantage, two main advantages over PARYLENE coatings are the fact that PARYLENE requires vacuum deposition, which is just incredibly expensive, slow. Oftentimes the batches are 5-hour processes. If you're doing high volume, then you're going to need to have multiple vacuum chambers for the deposition. These vacuum chambers are very costly. So the cost is high, it's slow, and then the labor and time involved in masking and demasking these parts is also extremely intense. And the masking is very difficult to do with the PARYLENE just because it has to be gas tight. If the mask is not done perfectly, the PARYLENE is still going to get underneath that mask and result in a coated, failed part. So now we'll get into some case studies. So these are examples of applications where we've worked with multiple customers and have successfully qualified and implemented the NanoProof series into production, and these are currently out and used in the marketplace. First example is Bluetooth headsets. So we've worked with a few customers to waterproof their Bluetooth headsets. They're looking for sweat and water protection typically. The requirement of full immersion is usually not there for these devices. So most of these customers are looking for in the range of IPX3 as a requirement, with IPX4 being a desirable. So in order to achieve success with this key customer, Aculon treated the customer parts and then returned those treated parts to the customer. They evaluated, identified areas that needed further work, and through a few iterations, we were able to get to IPX4 qualification in less than 6 months. And this customer utilizes NanoProof 4.0, and the application method that was determined is utilizing a PVA spray valve to spray all electronics except for the audio speaker. Another good application for the NanoProof series is wearable devices. Typically these are looking for protection from sweat and splashing water, but due to the requirement for outside connections, they're usually not looking for full immersion proofing, mainly just protection from rain and shower. Customer requirement for this application where it was commercialized was IPX4 with a desirable of IPX5. So for this application is a perfect example of why iteration is needed in order to achieve success. Due to the need for push-through connectivity, we tested the parts by spraying everything with 4.0. After that first round of testing, we had some failures on some of the high voltage components. We identified with the customer the failure areas, the high voltage components that needed additional protection, and through a few additional rounds of treatments, we determined that by spraying the board using the PVA valve with 4.0 and then utilizing a spot dispense application of 5.1 on the most sensitive and high voltage areas, we were able to surpass their IPX4 requirement and get them an IPX5 qualification. Another interesting area for these treatments is the protection of outdoor home electronics. So there's, as I'm sure you know, there's many new Internet of Things devices coming out, whether it's doorbells, security devices, you name it. And many of these devices need to go outside and they have complex electronics. And although the expectation for a full immersion in water is not there, they do need a pretty robust amount of protection from rain and irrigation equipment, which can be relatively high in pressure versus rain or splashing water. So IPX5 is required and IPX6 was a desirable for this application. So through many rounds of treatment and identifying failures and working through how to exactly treat all of these boards and connect them, we determined that the most robust option, 5.1, was needed due to the high volume of high voltage components over the entirety of the board, and that in order to eliminate failures at the connection points, we also needed to utilize 5.1 on the electrical connectors, which presented a small challenge because 5.1 doesn't have the native push-through connectivity. So that was solved by spraying the boards with 5.1 using the PVA valve, including the electrical connectors, and then later when going back to make the connections and actually assemble the product, the electrical connections were softened, or the coating on the connections were softened by using a little bit of 5.1 diluent solvent on those connections, softening the coating, and then making that connection with the coating in place, which protected the connector and the rest of the board. And the end result was passing IPX5 for that customer. Similar to the Bluetooth headsets, a great application for the NanoProof line of materials is hearing aids. So we actually have several customers in production treating their hearing aids, and a few more in the process of commercializing it. So as I mentioned, similar requirements for Bluetooth, looking for IPX3, IPX4 to protect from sweat and splashing water. These devices are usually fairly simple, and so this is a case where through some very basic collaboration and iteration, typically these customers obtain the material. NanoProof 4.0 has been what is recommended so that they can make their electrical connections easy, and typically it quickly meets their expectations, and they do this by treating all the electronics, utilizing the PVA valve, and simply not treating the audio speaker. And they achieve IPX4. And then, of course, what cell phone company doesn't want to achieve IPX7 on their cell phone so that they can avoid warranty recalls from splashing water, high pressure water, dropping the phone in a swimming pool, in the toilet, in a sink full of water. So that is, of course, in high demand. And so we're currently in direct collaboration with several cell phone manufacturers as we iterate towards IPX7 success. And what we've found is that every device is extremely unique and requires its own unique process. So depending on how the device was designed, there is a certain amount of collaboration that goes into determining exactly how to treat the parts with the nanoproof material, and then depending on the design and the exposure to the outside of any electrical components where repeated connections may be need to made, there is sometimes mechanical sealing or gasketing is required in conjunction for the overall device to achieve IPX7, but that is on a case-by-case basis, and we are currently working on utilizing 4.0, 5.1, and several experimental options in order to get to the IPX7 level with these test customers. And we're seeing extremely promising results, and we expect to hopefully be in production very shortly with some of these customers. So some performance considerations. Every device is different and needs testing. The performance requirement you're looking for will drive which nanoproof material you utilize, and it'll also drive the procedure. Each of these, the procedure and the nanoproof, will impact the coating thickness, it'll impact your cost, and it'll also impact your handling requirements in manufacturing process, or vice versa. In general, we do not experience impact on the following: the signal strength, Bluetooth, speakers, camera, antenna, as long as, depending on the material for speakers, that is, and as long as it's applied properly. There are several application methods that we can utilize as we iterate: spray, dip, and dispense. And then, of course, keep in mind that a cleaner board is better, so it is ideal, if possible, that if you have contaminants on your board, you do want to try and do what you can to clean them, clean any no-flux residues off. In some cases it's not necessary, but in general it is recommended. So how do you work with Aculon? Well, as I've talked about several times before, collaboration and iteration is critical, and Aculon ideally will work with you to determine the best application process so that you can have success in your application. We're very flexible and we have many options. Oftentimes customers will simply want to just buy NanoProof and test on their own, and we can certainly do that. But what's better is if utilizing Aculon's expertise in treating hundreds of different devices and working through these processes, if you're able to send your boards for us to treat directly and send them back to you, evaluate, give us feedback, and then proceed to a second and third round of testing where we eliminate any issues and get you to a point where you have a viable production process. And then of course the best method of all is if we have direct collaboration from the get-go, set up a design of experiments to determine the best treatments for application, and then further review results and iterate from there based on any issues that we see until you get to successful treatment.
Great, thank you, Mario. That was very helpful. As you can see, we've had quite a bit of experience, and we've given you some real case studies to give you some idea of not only the process but also the likely outcomes you can expect in working with us. So, you know, our business is supplying nanoscale repellency treatments, and we've got numerous applications not only in electronics but other areas as well already qualified. We focus on easy to apply techniques for treatments to provide protection. They are cost effective. A little bit goes a long way in these cases. And what we've developed here is, instead of a one-size-fits-all, we've developed a series of products that can provide you options to basically based on your performance requirements, so we can optimize for cost and simplicity in terms of process as well. So it's not always you want NanoProof 5.1 versus NanoProof 1.0. We'll work together to figure out which is the best way to do that. And certainly we believe that we outperform the competitive technology, and we're in a position to be able to supply globally to you. So with that, you know, we'll start to take questions in a second. So this presentation will be, the link will be emailed to everybody. There is also a link if you want to buy some samples for NanoProof, you can do that. And then obviously Mario is the right person to contact for any questions or volume quotes, because obviously what's on the web page, the shopping cart, is just for samples as well. So with that, why don't we get into a few questions?
Sure. So you will see in your control panel that there is a section for questions, so just go in there, and if you have any questions you'd like for us to address, just type them in and we'll see them all come in order, and we'll get through all of them. So let's get started here. I see a few are coming through already. So I see a question here: what components need to be masked? Does it act as an electrical insulator in connectors? And so the answer to that is, for assuming that you're talking about electrical connectors needing to be masked, connectors do not need to be masked for 1.0, 3.5, and 4.0 NanoProof. You can make the connection directly through the treatment with those materials. And the way that happens is that 1.0 is thin enough that the electrical connectivity is not impacted, and 3.5 and 4.0 actually set, once they set on the surface, they set into a gel-like nature, and then you can actually push through the parts or push through the coating to get the connection. With 5.1, you do need to soften the coating to make the connection, or you would need to mask that if you are not interested in doing that in your process. Next question is, how do you handle products with shields? How do parts under shield get protected? Well, the simple answer to that is that you apply the NanoProof before you apply the shield. If the shield can't be removed, you would either need to, if you have an access point where you can spray the material underneath the shield, that could be an option. You could try dispensing underneath the shield, and then you could also try dipping the part as long as there's no parts on that part that would be negatively impacted by the treatment. But ideally, this is done before any sort of shields are applied to the board. Next question is if MSDSs are available. And yes, the MSDSs for all these products are available directly on the product site, on the product page for NanoProof. And so we will also email out the link directly to that page, but those can be found on our website easily. There's an MSDS tab on that web page. Then the other question is how are excess chemicals disposed of? Due to the solvent nature, even though they are non-hazardous, they do contain flammable solvents, so that you would need to dispose of any excess chemicals in accordance with your local hazardous materials disposal requirements, depending on where your facility is. Next question is, does the NanoProof prevent tin dendrite growth? Will it encapsulate solder balls? So it will coat solder balls. Will it encapsulate them to prevent tin dendrites? That's unknown. We have not tested for that behavior. So it's possible there could be an impact, but the main focus of NanoProof is water protection, not the growth of tin whiskers. Next question is how much time from applying the solvent to making the electrical connection? So assuming you're talking about softening the part with the solvent to make a connection with 5.1, you would need to make that connection within about 5 minutes. So that would be something that you do. That is a step in the assembly process where you soften those parts and then immediately make the connection. It's not something you would want to let sit for an hour because it would harden up again.
And for the other treatments, it's not a time-based constraint, right?
That's correct. For 1.0, 3.5, and 4.0, there is no time constraint. You can coat the parts, let them sit for a week, and then assemble them a week later and make the connections. Next question is, where dielectric protection of a PCB is desired, can a conformal coating be applied over or under the NanoProof coating? So the NanoProof coatings are designed to be the topmost coat. Due to the repellent nature, they also act as essentially a mold release, so you would not want to try and coat anything over the NanoProof. But there is certainly no reason you could not put the NanoProof over a traditional conformal coating if you so desired in your process. Next question is, can you discuss the performance or number of cycles in salt fog testing and test cycle duration? So the testing that we did is the IPX level testing, and IPX is defined as an hour at 1 meter in those conditions underwater, and so that testing that we shared was not the salt fog testing.
But we have done some salt fog testing in MIR, right?
That's right. We've done some MIR testing, and that information is available on the website. Next question is, does no clean flux need to be removed? It is recommended that you remove no clean flux. It would act as a contaminant that could prevent the material from properly bonding to the PCB. But it is possible that it may not be required, so you could certainly test and try and see what the process is, or see what the performance is. Next question, have hearing aids been treated fully assembled in case or only the PCB assembly? Now, they've not been treated fully in the case because then that will treat the speaker and would act as have a damping effect. So you can treat the case and you can treat the PCB components, but you would not necessarily want to treat everything, as the microphone and speaker, which are highly sensitive for hearing aids, would be negatively impacted.
And it's we do have a customer that basically treats the outside of the hearing aids as well. It uses one of our other treatments, correct?
That's correct. So we do have one of our hearing aid customers treats the PCB, and they also treat the case with one of our other treatments, and that helps to prevent earwax and oil and sweat from actually getting inside of the unit. So it prevents any capillary flow between the connections of the case without actually sealing the case. Is the spray process air or airless? It is an airless spray process, which is how you were able to get extremely low overspray numbers. And so I think 99.5%, somewhere in that range, I don't have the exact percentage, is directed to where you want to be spraying the material. So there's no overspray. You're not going to get this misting out over the rest of the board where you don't want it coated.
Let me add to that. We showed some examples of PVA. This technology also works with Nordson's and Simtex and SCS's equipment as well. So PVA is a company we've just been working with. But if you have a preference for Nordson or others, then that is fine. We would just help specify what nozzle is required for these treatments. But we're not actually in the equipment business ourselves. We just give recommendations of that, and then as a customer, you would basically go directly to the equipment people to negotiate whatever pricing you can and get the type of equipment that you want.
Next question is, how is the diluent applied? So I assume this is for application of diluent on the connectors to make the connection with 5.1. Very flexible. It's just a liquid that needs to be put on the connector. You can use an automated dispensing system to dispense diluent. You can use a handheld syringe. You can drop a droplet onto the connector. That's a very flexible options there. Next question is whether you can ship by UPS in the US without hazardous material charges. For 1.0, 3.5, and 4.0, all of those materials do contain a flammable solvent. So all of those materials will incur a hazmat charge. 5.1 is not flammable and can be shipped without a hazmat fee. Next question is if there are any studies for tin whisker mitigation. At this time, we're not pursuing the impact of performance on tin whisker mitigation. The main focus here is on the impact of water protection and failure on boards. Let's see. Next question is, what is the highest voltage tested? It's possible we've tested higher, but we've recently done some testing evaluating the performance on parts for 8 hours at 13.5 volts in 5% solution of salt water, and those parts did not see failure with 5.1. So that is the most aggressive passing voltage that I'm aware of. Next question is, how thick is the coating applied wet and how thick is dry coating? So to refer back to the slide that discussed the different treatment options, each of these treatments is variable in thickness, and the thickness is really going to ultimately depend on a lot of factors. It's going to depend on how many passes you do, how many coats you put down, how fast you spray, the pressure. There's numerous factors impacting. In general, you're going to be looking at probably between 1 micron to 20 microns in thickness, depending over these factors. Another question addressing conformal coatings in conjunction, whether a conformal coating can be applied over NanoProof. Again, that's not recommended. NanoProof is going to act as a mold release, and it's not going to be good to try and bond a conformal coating to NanoProof. It should be your final layer. Next question is, what oil did we use for the oil contact measurements? That is N-hexadecane is the standard oil that we use for taking those oil repelling measurements. Next question is, how does NanoProof behave when reworking components on the PCBA? So if you are going to remove the NanoProof before reworking, you would want to just use a diluent solvent to rinse it away. And if you are going to rework without removing it, and as I mentioned, this does not always work, so it is a case-by-case basis if you will be able to rework without removing NanoProof. The NanoProof just gets burned away, is our assumption, but we've not done a study on exactly what happens there.
But you can replace a faulty component and then just spray back over that component.
Exactly. So if you if that's what you were asking, if you rework a part, then you just spray over that reworked part and it's treated again.
And so that can be done if you've got an automated spray machine like we showed. At the rework station, you may just have a manual device or even just dispense onto that particular component. So you wouldn't have to necessarily send it all the way back through the complete spray function.
That's right. Next question is, how does cleaning affect the coating? Well, that's a good question, and it will depend on which NanoProof you're using and what your cleaning method is. So that's there. That opens up a whole can of worms of possibilities. In general, the part should be cleaned, and the part should be prior to coating, and then coating should be the last step. So for the person who asked that question, if you want to email me with some more details, I can elaborate on whatever solvent or process you're considering and how that would impact our various treatments. But I don't have time to address all the different possibilities there, unfortunately. Let's see, a few more questions coming in still.
There's a lot more coming in.
Yeah.
It's great.
Next question is, does the coating feel greasy to the touch before it dries? And so, yeah, before it dries, it'll feel greasy or wet or solvent-like. And some customers also notice with 3.5 and 4.0 that if they touch a treated board and try and smear the 3.5 and 4.0 around, they will notice a greasy type feel to 3.5 or 4.0 after it is dried, and that is what allows 3.5 and 4.0 to have the push-through connectivity, is that gel-like nature. And so they should be handled carefully, and you should not treat the boards with 3.5 or 4.0 and then push the coating around by handling it. Next question is, if we're developing the nano coating for aerospace usage, and that would depend on the application. So I know a lot of aerospace applications are looking for tin whisker mitigation and a few other qualifications. This coating in particular is just designed for waterproofing. So if simple waterproofing is sufficient for an aerospace application, depending on what that application is, then yes, it can be utilized there. But for something that requires a hermetic seal or tin whisker mitigation at this stage, these would not be relevant for those applications. So this is a good question. What specifically about the circuit board design is a concern when applying the nano coating? So to give you a few examples, what we often get is we will try and treat a board with one of our mid-level treatments because really high performance maybe isn't necessary, and we'll see some failures on the board. And what turns out is that there's some high voltage components, and we need to identify that, and we'll apply a more robust treatment to those high voltage areas. Now, if a customer is able to identify to us which components on the board are high voltage, then we can know that going in. But oftentimes, either the person working on the project or they don't want to share too much information, it's not known to us which areas are most sensitive until we actually run through a round of tests. Another example of a problem we had to solve for one of our customers that's in production is we sent them some material, they sprayed the board, and came back and said, well, this BGA fails. It blows up right away within 5 seconds. And so, okay, well, that's not something we usually see at our facility, that there's an issue with the BGA, so can you send us your failed board? And it turns out there was no underfill in the BGA, and they sprayed the board top down, and so there was no treatment getting underneath the BGA. All the solder balls were exposed. And so we had to redefine the process to spray top down and then utilize a jetted spray at an angle to go under the BGA to treat that part, and that eliminated the failure. So that's an example of how the process and circuit board design impacts the performance. And so that wasn't necessarily a material failure, it was just a process failure that had to be, process issue that had to be identified. Next question is, what process or processes do you recommend for cleaning devices in order to ensure good adhesion? And the key thing there is, what is contaminating your device? So if it's a no clean flux, depending on the type of solder paste or flux that you have on your board, you would want to work with a company like Kaizen or Zestron that have numerous cleaning solutions. Work with them on what the contaminants are, and they will recommend a cleaning method. But the process for cleaning depends on what your contaminants are, and Zestron and Kaizen are really your best resources there because they're the experts in cleaning electronics. Next question is whether the material is VOC free. The answer there is for 1.0, 3.5, and 4.0, it is not VOC free. It does contain hydrocarbon solvents. 5.1 contains fluorosolvents, which in most regions is not considered a VOC, but that does depend on your local air board on whether or not fluorosolvents are considered a VOC. Another question on will it prevent tin whiskers. That's not something we've studied. It's not something one of our customers has studied yet, so that's still an unknown, and we're not directing this product towards that application necessarily. Next question is, what is the viscosity? All of these materials range from about 1 to 5 centipoise. They're very, very solvent-like and low in viscosity. Let's see. Next question is, does the Aculene stand up to mechanical wiping that a user will do on these parts? Most likely, it depends. So you would not want to use the lower grade materials, 1.0, 3.5, and 4.0, as those are, due to their ability for push-through connectivity, they can be easily damaged by abrasion, and so they're intended to be utilized inside of cases. 5.1 is a bit more robust because it does cure to a hard shell, but it is also not intended for abrasion durability. So that's a question mark. We'd be happy to work with you on that project, but it's an unknown as to how that would behave with mechanical wiping over time. Next question is the drying mechanism solvent evaporation or other? So that is correct. So the reason an oven or a UV cure is not required is this is a solvent drying application.
And for 5.1, if you did want to speed up the drying, you could put it through a oven or a temperature cure, right, to increase the rate of drying. But for 1.0, 3.5, 4.0 is not necessary, right?
That's right. Let's see. Next question is, what are the hazardous material ratings, specifically the flash point? I don't have those numbers direct in front of me, but they are on the MSDS, which is available on the website. What is this? And question also asking what the solvent used is. So hydrocarbon solvents for 1.0, 3.5, and 4.0, fluorosolvent for 5.1. Health rating for 5.1 is the hazardous ratings for 5.1 is all 0, and we can refer to the MSDS for 1.0, 3.5, and 4.0, which will be sent out after the presentation. Next question is if we've done any reliability testing with NanoProof. So we've run treated parts through multiple rounds of exposure to water without failure, and every one of our customers who has implemented this in production has their own set of performance and reliability testing, and clearly it's passed their reliability tests. Depending on what the reliability test is, everyone has their own unique set of standards for their application. So if you want to send me specifics on what the reliability testing you are looking to do for who asked that question, I'm happy to help elaborate. Next question is, will these adhere to flex connectors which are folded after coating? And so yes, these are very, very flexible treatments, and so you can coat flexible boards or flex connectors just fine with no issue. Another question on if it's possible to accelerate using a thermal cure, and yes, it is possible to accelerate using a thermal cure. It's not required though. Next question is pertaining to AIM no clean M8 flux residues, asking if it's compatible with NanoProof and if we've tested that particular flux residue. We have not tested that for compatibility, so for the person who asked that question, if you want to get in touch with me, we'd be happy to work with you on that to evaluate the performance there. Next question is the material expected to protect under large BGAs? So I got into that a little bit with discussing the iterative process, and so that is something where a process comes into play. So you would want to use an overhead broad spray on the rest of the board, and if you had a large BGA that needed to be protected underneath, using the automated equipment, you would change out the spray heads from a broad to a narrow jetted spray head, come at the edge of the BGA at an angle, and actually jet the material underneath the BGA to protect under the BGA. And that is something that we do with customers currently.
And that's part of the programming setup with something like a PVA application. They can have multiple nozzles, and so it would just be built into the programming to do that.
That's correct. The next question is, can NanoProof be sprayed with conventional HVLP equipment? And so there's two answers to that. Yes, you can use HVLP to spray NanoProof. Is it a good method? No. So HVLP is going to have overspray. It's not going to be directed. So if it is not needed to have any precision and it's okay to just get NanoProof essentially settling out all over areas that you're not intending to be coating, then you could utilize it. But it's very wasteful, and you're going to get overspray all over the place. So airless equipment from a company like PVA, Nordson, or SCS is highly recommended. To clean, and then the next question is, what do you use to clean the material out of the lines of the PVA machine? That's very simple. You would just use the diluent solvent. So for the 1.0, 3.5, and 4.0, you would just want to use a hydrocarbon solvent. For 5.1, a fluor solvent, which we can supply. So another question, which is a good one, is how scratch, chemical, and heat resistant are the 4.0 products? So I'll just get into all of the products to answer this question. So none of these products are intended to be scratch resistant. They're all intended to be used inside of a case that is not exposed to significant abrasion. 1.0 and 5.1 will likely have a bit more abrasion durability than 3.5 and 4.0, which offer the push-through connectivity. But yeah, you would not want to apply these to a consumer device on the outside and expect a long lifetime without reapplication. As far as chemical resistance, 5.1 is extremely chemical resistant to just about any solvent or oil or liquid. The only thing that's going to dissolve 5.1 is a diluent solvent, which is a fluorosolvent, which is extremely rare in most applications. Now 1.0, 3.5, and 4.0, which are hydrocarbon solvent based, are going to be resilient against aqueous solutions and water, but can potentially be dissolved by organic solvents that are similar to their diluent solvent. Next question is, and then also heat resistance. The upper heat limit for these materials is 225 Celsius. There is no known lower heat range, so you would want to keep these parts below 225 C to avoid damaging them. Next questions come in. For different application methods, do you need to add more solvent? Typically no, but you can, we can customize these materials for the application. And so if in your particular application the coating needs to be put down thinner or thicker, or due to some variable a change in actives concentration is needed, we can customize it. But typically, as these materials are supplied, they can be applied in all of these application methods exactly the same. For outdoor coated devices, can you clean it with soap and water and retain the coating? So the part can be cleaned with soap and water, assuming you're talking about the exterior of the part. That will not damage the coating. You would not want to treat the interior of the part with soap and water and any sort of abrasive action. But soap and water on their own should not damage the coating, and you should be able to clean the exterior of the device with soap and water. Let's see. Next question is, what percentage of solids are in the different products? And they're all in the range of about 1 to 5% solids. Again, we can customize that number if needed. Another good question is, do you need an oven, or can the solvent just flash off? And so yeah, the solvent will natively flash off. An oven will accelerate the flash off, and also a fan or an airflow would also accelerate that. The diluent solvents, next question is if the diluent solvents are readily available. The diluent solvents for 1.0, 3.5, and 4.0 are extremely available. They're just hydrocarbon solvents, very easy to obtain pretty much anywhere. For 5.1, the fluorosolvent can be obtained through chemical suppliers, but we can also supply that very easily, and we will supply it for your needs. Next question is the product number an indication of the percent solids? And no, the product number is just an internal Aculon nomenclature for these product lines, and it should not be taken to indicate that there is a particular percent of solids for any of these materials.
Okay, well, I think that's it for questions, and so thank you again for taking the time this afternoon to listen to us. We hope we have the opportunity to work with you to improve the performance of your product or provide some protection against water damage. We work in a pretty broad variety of fields, and if you have any specific questions, feel free to email Mario, whose contact information is obviously here. And again, thank you for listening, and we look forward to nanoproofing your products. And with that, we will sign off.